Welcome, everybody. Thanks for joining today. Axiom hosts a quarterly webinar on how data is being used to transform commercial refrigeration. This is our Q3 installation of that webinar series. Highlighting a few items as we get started today. As attendees on the webinar, your camera will be turned off and you'll be muted. If you do have questions during the presentation, that's great. We ask that you enter them using the Q&A tab at the bottom of your Zoom screen. It should be right there at the bottom. And you can enter questions there anytime. We're reserving the last 10-ish minutes to go through those Q&A, to go through those questions, and we'll try to address as many as we can. And Joel's going to moderate that. We are recording today's discussion, and we're going to make it available when that's ready, hopefully by next week. If you see or hear anything from our panelists that you'd like to learn more about, feel free to shoot me an email or Joel or anyone else on the panel. For any of the folks who are speaking today, and we'll make sure that gets to the right person and follow as soon as we can. So importantly, this webinar series and today is not a sales pitch for Axiom, City Building Engineering Services, Therm, or CoolSys. In fact, this is such an important topic that our panelists from CBs and CoolSys, who are some of the largest grocery store maintenance providers in North America, are putting aside their company's fierce competition to share their thoughts and perspectives on this really important topic, refrigerant leaks. So thank you both for participating in this conversation. I think this is great for the industry. So instead of being a sales pitch, this webinar is meant to start an industry conversation. Ideally, the retailers and cold storage folks and suppliers who are on the webinar today will learn from our panelists' experience with refrigerant leak detection, repair avoidance, and programmatic management. Our goal is really to help folks figure out ways to reduce their own leak rates, and there's no silver bullet that works for everyone. So let's do some quick intros, and then we'll look at the agenda. So my name's Amrit. I'm the CEO and co-founder of Axiom Cloud. I've been helping grocery stores and large commercial refrigerated facilities optimize refrigeration for over 10 years now. The reason that I'm really passionate about refrigeration is because it's a massive climate opportunity and financial opportunity, really in two ways. There's the energy impact of refrigeration, and then there's the leaks. And the leaks are absolutely enormous. And Fritz will tell us a little bit more about that later on from a climate standpoint. And there's a big opportunity there. So I'm a climate change guy. Those are two of the reasons that I'm really passionate about this area. So refrigeration, I view it as a massive overlooked and underserved category. We started Axiom a few years ago to really solve this problem, or the set of problems, using software and automation. And so I'm more excited about this new feature that we just released this week called early leak detection than any other technology we've introduced to the refrigeration industry to date. So it's already operating in 240 sites, and it's proven already that we can increase our greenhouse gas footprint by catching leaks early. We can increase our impact on greenhouse gas emissions by a factor of 10x. By catching those leaks a lot earlier compared to just doing energy-related stuff. So with that, let's talk about our other panelists here. Next up, we have Tom Matthews at City Building and Engineering Services.
Yeah, I've been in the industry working on these problems since before Amrit was born, unfortunately, and not his birth, of course, but the fact that I've been working that long. I've worked on both the end user side as Director of Facilities and Mechanical Services for Hannaford Brothers for a number of years. And then I went over to the other side and worked for Emerson for quite a few years before starting my own consulting company. And we operated at Baseline ES. We operated in Shanghai, China, France, and the US for a number of years. And recently, my team has migrated over to CBs. We've been trying to do, the people I've been working with have been trying to do the things that Amrit is talking about since the late 1980s, when EMS systems, building refrigeration control systems, I prefer to call them, started coming into general use. And we've been struggling and failing and failing. So any hint of success excites me a great deal.
Awesome. Next up, we have Fritz with Therm Solutions.
Yeah, great. Thanks, Amrit, and thanks for having me participate here. We're honored to be here. Background. So I was a co-founder and partner in a energy services and ESCO, commercial and industrial ESCO company called Groom Energy. For many years, we founded that company in 2005, sold it in 2016 to EDF, the largest utility in the world, actually, out of France. And I have been CEO of our new venture for the last 2.5 years called Therm. We are the leading refrigerant carbon credit developer in North America. We work in the voluntary carbon markets and the compliance markets in the US and in Canada. We have about 900 projects that we're working on, and we've minted and issued about 1.5 million carbon credits over the last 12 months. So that's kind of the short of it.
Awesome. Yeah, glad to have you here, Fritz.
Thanks.
And finally, Robert Eidson at CoolSys.
Yeah, thanks, Amrit. I've been in the industry about 30 years, started with Phoenix Refrigeration back in the early 90s. I've helped start up businesses, worked for 3 international companies. I can give you a day-long detailed resume, but really what I bring to the table is experience, 25 years plus field experience, and passion for the industry. So thanks for putting this together.
Yeah, I think that is really well put, Robert. The group of folks that we have on today's call, I lean heavily on for advice and advisory, basically. These folks are really passionate. They really care. And if you want someone smart in your corner who cares about the things that we all care about, refrigeration and the grocery industry and cold storage, these are some great folks to have in your network. So with that, let's go to our agenda for today. Quickly running through this, pretty self-explanatory. Why are leaks an important topic? What are the pros and cons of legacy methods for detection? Why is AI the future? And then basically how we're using AI today. And then what are the impacts of that from a maintenance profitability standpoint? And we'll talk more about the greenhouse gas emissions and carbon credits. We'll go into a couple of case studies, and we're going to do our very best to reserve a full 10 minutes for Q&A at the end here. And I'm going to try to be the timekeeper. So let's jump right in. Why are refrigerant leaks such an important topic? What you guys are looking at is a graph that I love to show. And on the x-axis is time, on the y-axis is cost. And basically, this is the story of one individual leak. And you can see that as time goes on, the impact of that leak gets greater and greater. Usually, historically, leaks haven't been detected until really 0.7 on this graph, when you start seeing temperature issues. You start getting case temperature alarms or space temperature alarms, essentially. And at that point, it's a huge emergency. It's a big reactor emergency. A lot of times folks will call it even, we're getting towards a rack fail situation. And so, Robert, leaks are common. Obviously, a lot of times leaks are found at 0.7. Can you talk a little bit about your experience? Does that match what you're seeing out in the industry?
So you're absolutely right. Normally, we don't see a predictive type leak detection. And some of the impacts that we see when I used to work for a retailer was it's not just on the maintenance cost, it's also on the retail cost. Because let's just break it down real quick. A store manager is normally bonused on their P&L, the profit and loss center, meaning their store. And every minute of every day is allocated or forecasted into what their employees will be doing. So when we have refrigeration failures, whether we're a service provider or installer, when we have refrigeration failures, the manager is not happy to see us when we arrive for a number of reasons. One is now you just put him over, or this system just put him over forecast on his labor budget, which is probably going to affect his bonus, his or her bonus directly, whether it's quarterly bonus or annual bonus. Plus, what this does to the product, I can tell you that there are billions of dollars each year of product thrown away because of spoilage. Spoilage can happen for a number of reasons, but one of the top reasons, I used to sit on the shrink reduction committee, and I actually consult customers still today on shrink reduction, and about 25% is in the refrigerated space and 75% is in the dry goods space. The 25% in the refrigerated space most of the time can be avoided. So it's a huge impact not only for the maintenance side and the energy side, but also the retail operations side.
Yeah, really well put, Robert. And then Tom, do you want to comment on kind of cost of refrigerant? So obviously, by the time we get to 0.7, it's almost too late. That's when we're seeing the massive business interruptions. But even before we get to 0.7, we're also seeing just really high cost for refrigerant, right?
Yeah, well, Amrit, part of the problem is that we actually have no buffer anymore. Because refrigerant leaks are common, most service providers are running the receivers in the systems, or many service providers, and the companies they work for, the clients they work for, they want receivers down near zero. They don't want to have a big charge in there, because when the leak that they feel inevitable comes, they don't want to lose any more refrigerant than they have to, because they wait until what had been 0.7. So the energy efficiency loss is there early, and the efficiency loss is there early because of this lack of confidence. In terms of the actual refrigerant loss, of course, it depends on the nature of the leak and the cost, but just getting somebody to the store now, never mind the replacement refrigerant, but just getting somebody to the store is $300 to $500 to get them to the store and back. Never mind the repair time, any gear that has to be replaced. So the impact is high in every way. But to me, the most significant impact is of not knowing when a leak has occurred until most of the refrigerant is, or a substantial portion is leaked out of the system, is the service providers have essentially been trained, and their clients, to keep the receivers as low as possible, which is biting them in the butt all the time.
Fair. And then Fritz, the piece that's not even shown here at all is the greenhouse gas emissions and the potential fines, and then also the carbon credits that could be collected if these were caught early, right?
Yeah, so there have been a lot of estimates done, but collectively for the 45,000 or so retail grocers in the United States, average size of about 40,000 square feet, there have been estimates of about 22 million tons of CO2 that's leaked annually related to refrigerants. That's huge, and the built environment itself is about 30 to 35% of the greenhouse emissions of the entire United States. For the retail grocers, these emissions exceed 50% of their carbon footprint, so it is significant.
Yeah, no, thanks for that context, Fritz. All right, so being the timekeeper here, let's keep going. So obviously, leak detection is not a new topic. This has been a thorn in everyone's side for decades, for generations, in fact. And there's a lot of legacy methods. There's case temperature alarms, which is one we just talked about. Basically, wait until it's a big emergency, and then rush to get fixed when it's already too late at that point. There's quarterly manual leak checks, where it's the kind of the sledgehammer approach, where you have people walk around every single store with a sniffer and hope to find leaks. But of course, that can only happen periodically, and if leaks happen in between, then you miss them. And then there's the parts per million sniffers, the ppm sniffers, the multi-channel sniffers, or the infrared sensors that are using threshold alarms to detect leaks. Obviously, the issue there is that if the leak's not happening near the sensor, then it's not really going to be caught. And then a lot of these it's tough to keep these operating properly over time. And then finally, receiver level sensor threshold alarms. So put another way, in that receiver, like Tom was saying, a lot of those are close to zero now. Getting a sense of how much liquid refrigerant is in that receiver over time. What does that trend look like over time? And that can be tough as well, if that sensor even exists, and it doesn't in a lot of facilities, in most facilities, from my experience at least. So at this point, I'm going to make a big assertion here, and it's really clear that I'm biased, right? Mm-hmm. But everyone kind of knows that software and AI are the future of this industry. It is the future of almost every other industry, and it's already transforming every other industry. It's just getting to our space today. And so I guess, Tom, when you're thinking about these legacy methods, Do you feel like these are working? What have you seen work the best? What have you seen work the worst out of these methods, or even others that aren't listed here?
Well, the one that I find most offensive is the quarterly manual leak checks, because that's a shotgun approach where we're sending technicians out to, in some cases, leak check stores that have no leaks. You know, that they don't know. A good leak check program says you go to every store on a monthly or quarterly basis and you check all the common areas of leaks. A leak detection system of any kind at least provides some targeting, but if an AI system can be very precise, then you're going to be using a laser to target those scarce service technician resources. And service techs are demotivated by going out and leak checking a store that has no leaks. We need to improve the environment they work in so we can retain more of these people. Going out in the middle of the night to handle a call, there's no refrigerant, there's a scramble to get refrigerant to the store. When that leak has been occurring for weeks, months, or at least days, and could have been repaired during regular daylight hours, regular working hours. That's what I'm concerned about. Those are the impacts that I find offensive. Waiting till you get a case temperature alarm is no longer acceptable in anybody's world. The sniffers have gotten much better. I can remember in the 1980s when the Yokogawa H10 sensor came out, and everything else was pretty much junk up to then, and except for the old halide, the putting a flame up and watching for the color change. But we have pretty good technology on the sniffer side. It just can't be everywhere, sniffing every place. So, to get the level of information we need something else. And AI has been the something else for a long time. I have my name on some patents from Emerson for determining refrigerant loss, refrigerant leaks using software back in the mid 2000s, but it didn't work that well. And we've my own company, Baseline ES, tried AI, and we did some pretty substantial tests and developed some algorithms, but we weren't successful. So we're excited that a system is here, and that it'll allow us to get ahead of the leaks and to target technician resources.
And Robert, you were talking about your experience with sniffers and requiring frequent repair and calibration and things like that.
Oh, it's horrible. Just in the last couple of weeks, I've been out in Texas and in Georgia visiting sites, and probably, just to be conservative, 50% of the sensors are actually still working, even the good ones. And I would say it's more like 75% are down. So we spend all this money to put these sniffers in. Tom was spot on everything he said, but one of the things I just want to bring up again is we don't know where the leak's going to occur. We have thousands of feet of pipe throughout a facility. We think it's all going to occur at the racks. We get a lot of leaks that occur at the racks. We hardly ever put a sniffer at the condenser. We get a lot of leaks at the condensers. So really, we are not looking, we're guessing. We're throwing darts at the board and saying, okay, we think the leak's going to come here, but what happens when it doesn't? We just lost the whole charge, right? We spent all that money for leak detection. Now, leak detection has its place. I believe it does has its place, like in life and safety, for like coolers, closed environments, freezers, stuff like that, where we need to evacuate in case we have a major leak within those spaces. But I think, and Amrit, you know this, I don't know if the panel knows this, I've actually been working on machine learning, artificial intelligence since 2010 when I left Danfoss. And I've actually consulted to 4 of the world's largest machine learning AI companies. And you're the first one that I've seen to really get this down pat, this algorithm down pat. I was recently working with Emerson R&D lab to develop a non-intrusive leak detection or refrigerant level sensor. Unfortunately, Emerson went through some downsizing before they sold recently. So that the R&D lab, we had it up and running. We actually had 4 customer locations picked out to try it, and it evaporated. So now you said here, very expensive and invasive of retrofit, modifying, recertifying receiver. That's absolutely correct. If you have to cut in that receiver, I would not suggest doing that. But there are some sonar technologies out there today that are non-intrusive that we can start looking at and using.
Yeah, the ultrasonic and the non-invasive thermal sensing stuff that you've worked on sound really exciting. Do you think that, like, what do you think the state of the art for leak detection will be in 5 years? For Robert?
I would love to see it move more toward AI. And when I say AI, just to be clear with everybody, AI is not something magical. It's really, what would a technician do? You know, what would a technician do to figure out that we're low on gas? I mean, some of the first algorithms, and a lot of the algorithms I use today, are really based on my field experience. What would I do if I was standing in front of that rack and doing this? And when you get down to your algorithm, there are going to be some people on this call and go, wow, that makes sense, because that's the way I would look and see whether or not I was having leaks. So I'm really hoping we move it more out of the physical on site. To Tom's point, we're really lacking in technicians, and we're lacking even more in good experienced technicians in our industry. So I would love to see some of that intellectual property go more into a computer that's monitoring a site 24/7, every second of every day, versus sending somebody out there every quarterly, whether they need it or not, to do a leak check.
And Amrit, on the leak sensor side, you do get quite a few false positives where you do have working systems. We've had an experience monitoring client stores where every time somebody goes into the bakery department and sprays a sheet pan to do some baking with the release grease, it triggers an alarm in the department. So our bit of expert system, or AI, was we had a note that on Tuesday morning at 8, when the refrigerant alarm came in, ignore that, because it's just the bakery personnel spraying their pans. So that is an example of the limitation of that form of leak detection. In terms of retrofits of ultrasonic, there's a company in the UK that did a whole bunch of retrofits. They're out of business now, called Ingenious, and they brought over the ultrasonic leak detection from the brewery industry, which of course is a positive in most of our opinions. But the problem is that determining the receiver level on a horizontal receiver, just the boiling that goes on in a receiver typically as discharge conditions change and there's momentary boiling in the system, it's very hard for the ultrasonic to accommodate that foaming liquid to surface region, and in a real refrigeration system, it's very dynamic. There's flashing going on all the time. The refrigerant isn't just sitting in that receiver being well behaved. So that makes the ultrasonic approach, while still very attractive, and AI itself could improve the interpretation of the information coming from those sensors, but they're still a little tough.
Yeah, great feedback. All right, we're going to have to rocket forward a little bit here. This is such a good conversation, but I want to make sure we get to examples. Okay, so everything that was just said, I'm really excited about. And I want to reiterate, like, this, in my opinion, this is the most exciting feature or technology that Axiom has released to date, is early leak detection using AI, because of the massive potential carbon impact and because it actually works. And we're already, showing some really exciting results, and we'll share those in a second. But I'm excited to get this deployed at scale like yesterday. So yeah, that's the next big challenge for us, is how do we get this into the market as fast as possible? And there's so many benefits here. So, no new sensors, no on-site installation. We can deploy it across thousands of sites really quickly, low cost. The bottom line is we can catch more leaks, we can catch them faster, we can identify the location of those leaks in most cases. And it's not location dependent. So no matter where the leak is in the system, it doesn't matter. The AI can still find it. And then ultimately, a lot of the stuff that's being done today, like these manual leak checks or these installing PPM sniffers in just a few locations in the facility. Those are done for regulatory reasons and requirements. And so in many cases, those dollars and those technician hours could be better used towards solving real leaks rather than, kind of walking around stores that aren't leaking, for example. And so we can help to eliminate, we check those compliance boxes, eliminate that unnecessary work while simultaneously reducing leak rates. So, how does it actually work on the AI side? I'm going to quickly run through this. So the early leak detection module that we announced this week for commercial use, it's already operating in, over 240 stores for about a year at this point. So now it's out of beta, it's fully released, it's now available all throughout North America. So we're using AI to identify system level changes in performance trends. And so a lot of times, we figured out, what is a leading indicator for a leak? And so it's not looking at any one trend, and it's not necessarily even looking at the same combination of trends from a site-by-site basis, because every site is slightly different. They have different sensors. We can trust some sensors more than other. They're located in different places, et cetera. Long story short, there's kind of 8 different families of indicators that we're using that the AI is using in order to determine, hey, something is not quite right here. Hey, there might be a leak. And so that's really the secret sauce here. That's the patent pending portion. But the whole idea is that we can do this without any new sensors. And the outcome is that we can track trends over time and detect a slow leak in 1 to 4 days. And so that's our kind of really exciting metric, I think, rather than waiting months for the next manual leak check or, missing PPM sniffer threshold alarms because, it might be a false positive because of a bakery thing or whatnot. And then at the end of the day, how do we translate this into action? And I'm going to give an example here. Even if you have the best early leak detection, if you can't translate that into action, there's no business value. And so we translate that into action by making sure that there's something incredibly clear and actionable that, and that's putting together a graph that a human can understand. So even though we're looking at hundreds of data streams behind the scenes, we're trying to boil this down into 1 or 2 different data streams with the right timestamps to help tell the story of what's happening visually to a human who's reviewing this, to make sure that they understand what's going on and they can explain it to their colleagues and they can act on it. And they actually believe that it's true. Because a lot of times people, are a little bit suspicious of AI, for example. So here's some results. Here's the most. So I pulled this report earlier this week. It summarizes the 16 most recent leaks we detected early for one of our large customers. There's a pretty good representative sample. So you can see the leak rates, you can see the leak durations, and then how much was lost in each leak. And this is the actual amount that was lost. And then ultimately, how much did we save because of early detection? And so we're making the assumption here that these leaks would not be caught until 0.7 on that graph that we showed earlier when you start to see temperature issues. And so, take that for what it's worth here. But I want to point out a couple of examples. So if you look at, here, I'll annotate here. 2, 3, 4, 5. If you look at this leak here, the 5th one in from the right, you can see that this is a pretty low leak rate, maybe 1 or 2 pounds per day. 1, 2, 3, 4, 5. But this leak went on for 289 days. And so even though it was a low leak rate, it went on for such a long time that we ended up dumping, nearly 600 pounds of refrigerant. And so this is an example of, hey, we, even though we detected this, ultimately that action was not taken to resolve it. Or if that action was taken, it still wasn't resolved. Maybe it was some sort of fix. Maybe a technician came in and said, oh, I tightened up a Schrader valve, but that actually wasn't where the real leak was. And so as a result, Axiom did not deliver any value here. Put another way, 0 pounds of refrigerant were saved due to that early leak. And so again, I'm just highlighting the fact that no matter how good that early detection is, if action is not taken, there's no business value to be had here. And so taking that early leak detection and translating it into value, that's another major piece of the puzzle that Axiom is super, super focused on, because that's where the rubber hits the road. And that's why we partner with folks like Tom and CBs for certain customers as well to make sure that that action is taken. So contextualizing this a little bit, we saved about 1,982 pounds of refrigerant over these 16 leaks. That's equivalent to 4.6 million pounds of CO2. And then Fritz, I think you were mentioning yesterday, that's about $60,000 worth of refrigerant gas savings alone, ignoring all the other savings from avoided emergency rack outages. Fritz, can you help us kind of contextualize what is 4.6 million pounds of CO2?
Yeah, so sort of stepping back and looking at the monetization of leak mitigation. The charts you're showing and the reduction in by using AI, by using leak detection systems can be monetized. And here we're talking about 4.6 million pounds of CO2 equivalent, right? Avoided CO2. And we actually did it at FMI last year, where we co-presented with Giant Eagle. And in that particular case, we were saving each of the stores by monetizing those improvements, the actions, Amrit, that you talk about, not only the identification, but the actions that both Tom and Robert's groups actually have to execute in order to reduce the leaks. On a per store basis, that the equivalent of the carbon credit value on an annual basis is about $1,500 to $2,000 per year per store. So in the case of Giant Eagle, that's about $250,000 a year that they're able to monetize. And that is for either 1 or 2 crediting periods, which can add up to about 14 years worth of annuity. So the carbon equivalent avoidance directly translates to carbon credit value.
Awesome. And so what that requires is you got to catch the leaks early, you drive down that leak rate, then you have to be able to quantify the value of this early detection.
Right.
Yeah. So yeah, that's why we're so excited to be working with Fritz, because we're checking those boxes, obviously. Look forward to, unlocking that value for more and more customers. All right, let's actually skip over this slide. I think this was really meant to talk about a couple examples of persistent leaks that are causing a lot of pain. But I think we've addressed this topic adequately. So Fritz, let's jump right into RCCs. And so with that, what is an RCC, and can you get carbon credits for leak detection?
Yeah, RCC is our trademarked version of carbon credits, and refrigerant carbon credits is all we do at Therm, right? That's all we focus on, trying to monetize these environmentally positive actions to help retail grocers and food distribution invest and lower CapEx. So what's an RCC? An RCC is an avoided ton of carbon dioxide. So if on the left-hand side, if you're replacing climate damaging refrigerants like 404, for example, with about a 4,000 GWP global warming potential with CO2, the difference between the old gas and the new gas times the expected 25% average leak rate, or your actual leak rate over a 10-year period, is what is calculated by our engineers in order to figure out what that ton of carbon is worth. And then in order to monetize it, we actually take on the responsibility of selling those carbon credits for our retail grocer partners and ourselves into the marketplace to big buyers like British Petroleum and Amazon and Shell and all these sorts of folks. The value of one of those carbon credits for a commodity, which you may have heard for things like forestry credits or those kinds of things, is about $1.50 a ton. We're pleased to say that over the last year, our range of value for selling carbon credits into the marketplace has been about $6.50 to $9 a ton. So we get a significant premium to the commodity price.
That's because of the superior quality.
Yeah, it's about the superior quality, the permanence. You may have heard the word permanence, right? Some forestry credits are in some cases deemed dubious, right? Because of things like fires, drought, pestilence. whether or not the carbon credits or the forestry carbon credits are just moving harvesting of wood and pulp to another part of the country. So we don't suffer any of those issues with refrigerant carbon credits. They are actually by B0, they're rated A rating by the biggest rating agencies in the world, or rating agency in the world, and that's for the top 7% of carbon credits traded in the world. So our retail grocers are pretty proud of that, and we're pretty proud of them for these actions.
And so there's two types of categories here. One is, swapping out refrigerant for CO2, for example. And then the one that we're focusing on more today is about reducing leak rates.
Right.
Am I getting that right, Fritz?
Yeah, so it's a similar scenario, Amrit, with leak rate reduction. First, it takes an action, right? You have to engage great companies like Axiom, right, who have substantial technologies to allow us to understand where leaks are, right? And then you have to take action. So it's a difference between your baseline, which we help establish, or you may have already established a baseline leak rate, and what those actions occur again for that 14 years. So the difference between maybe a 25% leak rate without action, and then in installing systems like Axiom's leak detection system might drop that 25% down to 15%, 10%, something like that. But every year we recalculate that, and that is the value that we take to market.
Perfect. And I guess that's getting straight into the next question, which is, how are leak detection credits calculated and issued? You just addressed that. How does this deliver a new stream of revenue? You talked through that. If you're a grocer and you report on ESG or you report on carbon, are carbon credits relevant to you?
Yeah, so carbon credits are for new construction are very relevant, right? There was no carbon footprint before, there's no carbon footprint after. So they don't affect a large retail grocer's carbon footprint. For our very largest of our customers who want to maintain those environmental attributes and not sell them, things like retrofits or rehabs, where you're going into an existing store and you're taking out an HFC system, those you're selling the rights, so you can no longer claim a reduction in your inventory, your greenhouse gas inventory. You're selling the rights to those folks I talked about before, the British Petroleum, the Shells, the Microsofts who buy those. They're taking those credits for a period of 10 years. After 10 years, you can take the inventory reductions, but you've made a choice again for retrofits, rehabs, as opposed to new construction. New construction, there is no effect on your inventory.
So if you want to show a great ESG credentials and lowering your carbon footprint, you don't want to sell your credits. In fact, you might want to go and buy credits. But if you don't care about that so much, and instead you want to improve profitability, maybe this is an opportunity to go and improve profitability by selling some of those credits. Is that right?
That's true. That's true.
Got it. Okay. Super helpful, Fritz. All right. Let's jump into an example here. So this is a case study or a customer story that came out this week as well, actually. This is with Sprouts. It's a location in Northern California and in Sacramento. And so this facility started leaking 407F refrigerant. No receiver level alarms were triggered, and the leak detector was out of calibration, so it was being ignored. It's one of those things where there were so many false positives that it was the boy who cried wolf, and everyone was ignoring it. And so, here's what it looks like in data. So there was basically, we detected a leak using those 8 system level indicators, or 8 families of indicators, I guess would be more accurate here, to estimate the relevant changes. We reached 98.5% confidence in that leak. And so one thing that's really important here is that I'm showing you guys a graph of receiver level and outdoor air temperature. These are not the data streams that were used to catch that leak. Instead, these are the data streams that were used to explain the leak to humans who are now we're asking to act on that leak. So if we showed them, this massive quantity of data across 15 different set of axes, they would just, their eyes would glaze over, they would ignore it. And so the whole idea here is, how do we communicate this so clearly and simply that a technician is going to look in this and be like, yeah, duh, there's a leak, I'm going to go fix it. So we reached that really high level of confidence where we're ready to put our stamp on it and say, yes, there's a leak. It's time to roll the truck. From there, the Sprout service manager opened a high urgency work order. She copied and pasted the anomaly notification directly into that CMMS. And so that helped the technician a lot. That made that even a less qualified technician more likely to succeed, and helped them to speed them up here. Ultimately, they went in the next day or later that day, and they found the leak, they fixed it, they refilled the system with 50 pounds of gas. And so, we were on our way to a rack fail here. And the service manager estimates it would have been another about 200 pounds of gas, and then a really disruptive and painful situation when they ran out of gas a couple days later. However, as you guys can probably see, the story doesn't end there. And so we did detect another leak on the same system about a week later. So this is leak number 2 in the same sequence. And so another high urgency anomaly notification was sent. Again, she copied and pasted that work order directly into the CMMS as a work order. The service technician showed up and ultimately realized that just by tightening up everything on the rack, they were able to then reduce that secondary leak or eliminate it. And so the no gas refill was necessary because it was still, above 30% in the receiver. And so the service manager estimates that would have been another 100 pounds of gas lost within about 5 days, and another, big, expensive, stressful rack fail situation within about 5 days had the leak not been identified. And so ultimately, part of what Axiom does also is we're using data to confirm that the root cause of something has been resolved before we're closing it out on our end. And so in this case, it took about 11 or 12 days to then confirm that, this is fully resolved. It doesn't mean we stop monitoring, to Robert's point from yesterday, but it does mean that, we're marking this as a success. And if there's another leak on this rack in the future, we're going to count that as separate. So, bottom line here is, we helped them to avoid hundreds of pounds of refrigerant loss and avoid 2 critical cooling outages in a week. So, really big win. And we're excited to be partnered with Sprouts on this. And again, this is, one example of many. It's not because Sprouts is more leaky than other folks. It's because, we're all in the same industry and we're all experiencing the same problems. I think Sprouts is actually quite good when it comes to leak detection. And so we are running pretty low on time here. And so what I'll do is really quickly, why don't we actually skip right over these other case studies? I guess, let me talk about it super quick here. So here's another case study where basically, again, we are explaining the leak by showing these same two trends, which are receiver level and outdoor ambient temperature. But again, the leak was not detected using that receiver level. And so ultimately, this was one where, again, it wasn't caught by ppm sniffers on site and the receiver level sensor hadn't gone off. We were able to catch it, much in advance of either one of those threshold alarms. In this case, this is an example of how we're able to locate a leak, which I think is kind of cool. In the worst case scenario, we can tell our customer or the technician which suction group the leak is on, or if it's on the high side, which liquid group the leak is on. But in most cases, we can actually be much more granular than that. We can tell you which display case, if there's case controllers, or which case group it's in. Or which evaporator group, essentially, if it's, in the walk-ins or whatnot. And so this is an example where, and again, we're showing the leak here using ppm sniffer data in order to help exemplify it. But ultimately, you can see that the ppm data or the ppm levels dip a lot when this one particular case group, this one particular circuit goes into defrost when that solenoid shuts. And so voila, we can tell you that leak is on that case group, because suddenly the leak stops whenever it goes into defrost. And so this helps the technician, rather than spending 2 hours walking around the facility with a leak detector, they can go directly to that one case group and look at those 3 expansion valves. And, maybe they only need to demerchandise one of those rather than, doing their best to find the leak in a 40,000 square foot store. So with that, that brings us to the end. And I'm very proud to say we have reserved over 10 minutes for Q&A. So let's jump straight into that. Joel, do you want to kick us off here?
Yeah, we started out by saying that we have some some spicy panelists today. We're starting to get some spicy questions into, and a lot of them around sort of that last phase where it's like, sure, we detect it, but we have to go back out and still do something. And so the first one that's coming in is, my maintenance provider pays for the gas. So where's the value here? Is there additional value beyond just the gas savings?
Yeah,
This is
that
one for
I'd like
Robert,
to
I think.
answer that. The structure of typical refrigeration maintenance contracts hasn't changed for 30, 40 years, and it's kind of ridiculous. There's no incentive for the contractor, for the client, when they write these contracts. They're essentially 30% service, 70% insurance. Tools like what Axiom has here and many other tools available in the industry now argue for time and material services. In that instance, everybody would benefit directly from where they were successful and would be punished where they're not. And my other feeling is that service contractors need to be paid to help us reduce leaks. If a store manages to reduce its annual refrigerant usage 50% over its historical average, and the efforts of the contractor were part of that, whatever contract they do end up having ought to reflect that. If you want to get stuff done in this country, you pay for it. If you want to reduce your refrigerant leakage rate, the key instrument is that service provider and the software like we're talking about now. Everybody's got to get paid or we're not going to make any progress.
Robert, you had mentioned the split incentive a little bit previously, having been on the retailer and the contractor side. Do you want to speak on that?
Yeah, so that question in itself, so the contractor, yeah, may be responsible for the refrigerant, but he's not responsible for your energy bill. And he's probably not responsible for all the spoilage. Even if the rag doesn't go down, if it's running lean and you're not making good product temperatures, meat, for an example, it has a limited shelf life. It is a high dollar product. And if we're not keeping enough refrigerant in there to keep a good temperature, consistent temperature on that meat, we can lose 2 days on shelf life. So refrigerant is just part of the equation and the cost and the total impact to the business. So and I know Tom's been on this side. I've been on the retailer side and the vendor side and the engineering side. So I see it from a lot of different angles. So when we talk about refrigerant being the contractor's responsibility, okay, but there's a lot of other impacts that, in fact, if I was on the retailer side, that would impact my business, and my operation, my sales, and my customer presentation. There's a whole bunch of things that are directly impacted by that.
And I know that we say this in basically every single quarterly webinar, but my perception is that a big part of the problem here is that, we're treating technicians incorrectly in the space. We're forcing them to go faster and incentivizing them to use Band-Aids rather than solving root cause, because it's all about low price. It's all about, everyone cares about price more than quality at this point. And so that's putting everyone in a tough situation, especially technicians, because they have to go faster and faster. And ultimately it's about keeping food cold now rather than it's about solving root cause in many cases. At least that's my perception. Robert, Tom, any reactions to that?
So I can tell you we're 160,000. So in 1988, when I graduated high school, we had they were getting rid of the automotive school and the woodworking shop. And so the federal government decided to go down the social engineering experiment where everybody had to go to college. When I worked for a retailer in 2013, our average technician age was 55 years old. Today, according to the Federal Labor Bureau of Statistics, we're 160,000 technicians short in our industry. And the ones we do have, I would say 40 to 50% of them are not qualified or they don't have the experience needed. So not only are we're missing 160,000, but the ones we do have are not where they need to be before they get dispatched on calls. So we got to improve our analytics and to y'all's point and to your point, I mean, just something as simple as putting a refrigeration system over a walk-in cooler where you got belly crawl to the refrigeration unit. We haven't thought about the technician, the serviceability of this for years, and then we complain because it cost us X amount to get the guys out there. Well, we pay for low-dollar installs because construction doesn't want to talk to the construction and maintenance are at odds with each other. Energy is at odds with all of them. Everybody, what I found is working for these big companies is that you can have a department sitting across cubicles from each other, and they won't talk to each other because there's some kind of political something going on. So they can't lay that down for the betterment of the company and all the employees who work there and all the customers who shop there. So that gets in the way. So when we talk about the technicians are probably they're like the gum on your shoe. They're like the worst. They get the worst from all ends.
And Amrit, I think the accurately predicting not just refrigerant leaks, but other system possible failures, the icing, the early signs of case icing, and a number of other key algorithms of that type can dramatically improve the lives of the refrigeration technicians we do have by getting them on a regular work schedule. That is what drives people out of the business. Their spouses are angry. They're not there for their kids, for weekends, nights, and it's mostly unnecessary. There aren't that many catastrophic failures in our business. You almost always could see them coming. We have the sensors in place to see them coming. We just don't have the eyes yet. We haven't, or the eyes are there and we haven't connected it to the brain. And that's the kind of work that Axiom's doing and other companies as well. But everybody in the industry has to get smarter and fast. It's ridiculous that anybody who worked on automobiles back in the 60s and 70s and experienced that, and now look at what the cars do now. They tell you when they're broken. They tell the service technician what they need to do. This is the level we need to be bringing refrigeration systems to. People complain constantly about the new CO2 refrigeration systems, particularly transcritical, not being able to get service for them. Well, turn it around. What if those systems had such completely smart control systems that they essentially saw trouble coming, told the service providers it was coming and what they needed to do. So when that tech was heading to the store, they knew what was wrong, what part they needed to have with them, and how desperate the situation was. That's always the expression I use. It's a better ride to the store when you know what problem you're going to face. If all you know is the refrigeration is down and everything's getting warm, that's not a pleasant work life. Send them to the store with the knowledge that they're losing refrigerant or one of the condenser fans is going to fail, and let them have an orderly work process. But that's going to take much smarter systems, much smarter.
Amrit, I want to say one last thing. Sometimes I've been accused of being down on technicians. I am not down on technicians. I'm a huge supporter of technicians. Spent most of my career in the field. I feel like I'm being real with where the industry is today and where I've seen it come over my 30-year career here. And it sickens me to know that we haven't taken more steps as an industry to shore up our technicians and to build better, and like Tom said, more analytics and smarter systems into our refrigeration and our controls.
Yeah, well put. Joel, what's next?
Yeah, I think that's a good segue, Robert. There's some questions on, so how are we using this data to make those technicians' lives a little bit better? And I think it's a little bit of how do the AI systems work in general? And so, Joseph, I'm going to try and summarize all of your questions here really quickly, but it's really AI systems are pulling data, a lot of data out of the refrigeration systems. Where are they getting that data? Is there anything special that those systems need to have as far as sensors or commissioning? Do they need to be in a certain state? where does the system need to be before we can start implementing AI detection for leaks?
Well, Amr can probably answer that best, but a store with case controllers on it, on the evaporators and the refrigerated fixtures, has a lot more information available than a store that's a simple suction stop or even less informative EPR only control for temperature. But nonetheless, each one of those systems can benefit from an expert system, an AI system, analyzing the data that is available. You get better results if you have more data granularity. There's no question about it. It's another reason to put more complete refrigeration control systems in, and finally adopt case controllers and electronic expansion valves. But you still get value, and Amrit can speak to whether or not this algorithm will function successfully with we'll call it a bare bones control system.
Yeah, key takeaways, or I would say to summarize, you do not need to add new sensors. The system, like with Axiom at least, we've designed this from the ground up to be incredibly flexible because there is such a wide variation of what's out there in the field today. We can't go back and deal with the control systems. So you got to have some sort of advanced controller, like like an E2 or something newer than that. That's kind of our main constraint today. It can't be super old or dial up or something like that. And there has to obviously be a controller. But beyond that, we're dealing with stores that have 50 or 60 data streams. We're dealing with stores that have well over 1,000 data streams. Some of them have case controllers, some of them don't. All kinds of different refrigerant types. Yeah, all kinds of different, every manufacturer of racks and compressors and valves and controllers, et cetera, out there. So yeah, it's all about the flexibility. And just like Tom said, the second key takeaway, more data is going to drive better outcomes. So if we have case controllers, you're going to have way better outcomes than if you only have 50 data streams.
Yeah, let me that's a good segue on the next one too, Amrit, is how sensitive is this leak detection using AI? Can you detect small quantities of leaks, and how does that relate to false positives, or and how does that play into this? Because I think the last thing anybody wants is having a AI system telling them they've got a leak when there isn't one. So could you talk a little bit about the sensitivity of sort of AI systems like this, and then also sort of any idea around the false positive rate?
Yeah, I mean, from a sensitivity standpoint, like we're catching leaks as little as 0.3 pounds a day. So pretty darn sensitive. If it's substantially less than 0.3 pounds a day, that's going to be the type of leak that's just going to take a lot longer to detect, honestly. So, these types of leaks that are, a quarter of a pound up to 50 pounds a day, these we can detect in just a handful of days. We say 1 to 4 days. If it's substantially less than that, it might take us a week or 2 weeks to detect it. But it's honestly like the impact is so much smaller, it doesn't matter at that point. In terms of false positives, one thing that I mentioned in the case study is that we have a really high threshold. It's about 98.5% confidence before we're sending out leak notifications to customers. And I will admit there have been false positives in the past, but it's a very low rate. When there's a false positive, that's something that is brought to me. I'm the CEO. And so I've only seen a couple of those thus far. Out of the hundreds of these, don't quote me on that, but there's been a lot of these that have gone out. So, and another really important piece is that we do at Axiom at least have humans in the loop on these. So the whole idea is that we're not spamming out hundreds or thousands of these a week. We're sending out really targeted small handful of these that are the most impactful, the most important, that need to be acted on. Because at the end of the day, we don't measure value based on how many anomalies or issues we send, or what the value would be if they fixed all those. Instead, we measure business value based on how did we partner with our customer to deliver actual business outcomes that resulted in true savings. So it's about how did we drive action rather than how many notifications were sent. So I think we're actually at the hour here, so we're going to have to pause. There's some other really great questions in the queue. Joel, can you and I and other members of the team get back to these folks via email?
Yeah, so Joel and the other people that have questions, I'm typing out responses right now, but we'll make sure that we get those answered for you, and we'll follow up on all that here shortly today.
Perfect. Yeah, thanks all for participating and being a part of this. We will send out the recording to everyone here. Feel free to reach out to anyone on the panel, and we'll be sure to route that question to the right person and get back to you as soon as we can. We're really excited to be a part of this industry conversation with everyone here.
Great. Thank
Yeah,
you.
thanks, Amr.